Welcome to Cheenta Statistics and Data Science. Today we're going to solve this problem from CMI Data Science 2022, problem number 15 and 16. So let's start with problem number 15. It says that which of the following expressions take integral values for all integers n greater than 100? So basically these expressions we have to check, are they integral or do they take integral values or not? So let's start with the first one, 3 to the n minus 1 by 2. So see, it can be done in various ways, but it can be done using the congruence modulo in number theory, which is very easy. But since we don't have that in the syllabus, we are going to use the very simple way. It's also quite simple. See, a to the n minus 1 divided by a minus 1 is actually nothing but 1 plus a square plus a cube up to a to the n minus 1, right? Where is positive. This thing, this thing, in fact, this is a is greater than 1. A is going to be greater than 1, right? See, this is nothing but the formula of the geometric progression, right? Of the summing of the first n terms of a GP. So this thing is true. This is an identity, right? So for a equals to 3, we can just put for a equals to 3, 3 to the n minus 1 divided by 2. This takes the form 3 to the n minus 1 divided by 2 is nothing but 1 plus 3 square plus 3 cube up to 3 to the n minus 1. Now this part is clearly an integer, right? A positive integer, because this individually these are all integers, so the sum is also an integer. So this entire thing is an integer. Now this is nothing but this part 3 to the n minus 1 by 2. So this thing is actually an integer. Therefore, no matter what n takes values of, this is true for all n, not just for n greater than 100. This is true for all n, so obviously it holds true for n greater than 100, right right. So this part is true. So first one is actually does take integral values. So option A is true. So let's check the second option. Second option says 4 to the n minus 1 divided by 2. So see 2 divides 4 to the n, right? Because 4 to the n is always even. So 2 divides 4 to the n. This is the symbol of for 2. This denotes the symbol of division. So 2 divides 4 to the n for all natural numbers n, right? Now, since 4 to the n is even for all n, right? Now, 4 to the n minus 1 therefore is odd for all natural numbers n, right? Because since 4 to the n is even, therefore 4 to the n minus 1 is odd. Therefore, 2 does not divide 4 to the n minus 1 since this is always odd and 2 cannot divide an odd number, right? So, this thing 4 to the n minus 1, this part is odd, divided by 2 is not going to be an integer, right? So, this does not belong to the set of integers. So, no matter what n takes, no matter what value n takes, this is not going to be an integer. So option B is not going to be the answer for this problem. Option A is going to be, but not B. So let's check option C. It says 4 to the n minus 1 by 3. Now again, just using this formula, this thing, just putting A equals to 4, we get 4 to the n minus 1 by 3 equals to 1 plus 4 square and so on up to 4 to the n minus 1, which obviously just like the previous reasoning, this thing is clearly an integer. These are h's, so obviously the lh is also an integer, right? So 4 to the n minus 1 by 3 is going to be an integer, right? Very easy. So this part option C is also true. Now option D says 5 to the n minus 1 by 2. Now see, 5 to the n is always odd, right? This is odd for all natural numbers n, right? So 5 to the n minus 1 is going to be even. See, 5 to the n, 5 to the 1 is 5, 5 to the 2 is 525, and 5 to the 3 is 625. So 5 to the n is always going to be odd. So 5 to the n minus 1 is even for all n. And since it is even, therefore it is obviously divisible by 2. So 5 to the n minus 1 by 2 is an integer, right? Very easy. It is an integer. So this again belongs to the set of integers. Therefore, 5 to the n minus 1 by 2 is, and it takes integral values. So therefore option A, C and D are all true. Option B is false. I mean, option B does not take integral values. This one, option B. So A, C and D take integral values. Right? Very easy problem actually. We could have also used congruence modulo, but yeah, this is also quite simple to use, right? Very easy. So yeah, there you have it. The solution to this problem. Let's move on to the next problem. See, question 16 says, at a conference attended by 1235 people, 1235 people, some attendees shake hands with the other attendees. As a part of the local COVID-19 tracing protocol, the organizers asked each attendee to note down the number of other attendees with whom they shook hands. Let n be the sum of all the numbers noted down by the attendees. That is, n is the sum taken over all attendees of the number of other attendees with whom they shook hands. Which of the following is guaranteed to be true about n? N is always a multiple of 1235, n is always a multiple of 2, always a multiple of 3, always a multiple of 5. So basically, we have to find the nature of n. See, not all of the attendees shook hands with all the other attendees. It just said that some attendees shake hands with other attendees, right? So it might seem a bit difficult because you don't know how many of them shook hands with others, and right. So this is a it might seem a difficult problem, but it's actually very easy. See, if a person I shakes hands with the person J, that means say if we can just for consider that each of the person has a number as a ID card showing person one, person two up to person 1235, then we can just call that this if the person I shakes hands with the person J, then the total number of handshakes is increased by two. Why? See, n counts the total number of handshakes. So each of the person basically so every person say person one returns the number of say, person one what to say informs how many hands he or she shook, right? It can be zero or it can be one or two or three, whatever, and it regardless that whether other persons have already counted or not, each person is independently informs that how many handshakes he or she had. So say it can be zero or one or two or whatever. So whenever see when if person I shakes hand with person J, then I obviously is going to inform that he shook one hand, right? He shook a hand with J, and again person J is also going to inform that he shook a hand with I. He or she is also going to count that handshake. So every handshake is getting counted twice, every handshake, right? So this if I and J shook hands among them, if I and J, then it's going to be one with respect to I plus one with respect to J because I informs this handshake from his or her perspective, and the same thing is done from J, right? From J's perspective. So every handshake is basically informed twice, exactly twice. So if initially the capital N is zero, that means it just increases every time someone informs the number of handshakes. So every time n is actually increased by 2. Every time two persons shake their hands, n is increased by 2. Therefore, 2 divides n because n is initially 0 and every time a handshake is done, it is increased by 2. So if ultimately the amount the n that the ultimate amount of n is actually going to be even, right? So n is going to be divisible by 2. Very easy, right? So n is actually a multiple of 2. Very easy. So this problem might seem difficult at the first glance because we don't know how many attendees shook hands and all that, but it's actually a very easy problem. It can easily be known that n is going to be an even number, right? This is the this is the main problem. This is the main fact of this problem, the main trick that if the person I shakes hands with person J, then the total number of handshakes is increased by two because every handshake is informed to the total is it gets counted twice, one from the perspective of the each of the persons, right? So that's the thing. So very easy, right? So yeah, so there you have it, the solution to this problem. So do like, share, and subscribe to the channel for more exciting problems. See you till next time.